Hi, my name's Will. I'm a product manager from Hortonworks. Hortonworks has recently launched a cloud offering that allows you to run large-scale data analytics in Amazon Web Services cloud. Today, I'll be showing you how to set it up, as well as running through some simple examples. To get started, you can go to hortonworks.com and then click on Products. And under Products, you will be able to find HD Cloud for AWS. By clicking on the Try Now button, you will be landed in Amazon Marketplace. In here, you will launch the Hortonworks Data Cloud Controller Service. The Controller Service is the top-level service that will allow you to manage multiple clusters. To get started, pick a region. In this case, I'll be using US West origin region, and then I click on Continue. Once the page loads, it will ask you how do you want to make payments, the versions, as well as more information for this. I'll be using the default configuration. Launch with CloudFormation console. So HD Cloud uses CloudFormation, which is a virtual machine fleet management service that allows you to launch multiple machines. In this case, we'll be launching only one machine. Using the specified AWS S3 template, this is how we provide the deployment template to the Word. So you don't have to change that. Click on Next. The stack name. So this one is something you can name by yourself. In here, I'll do HDC tutorial. The instance type, I recommend M4 large for simplicity, but you can also use others. I type in my email address as well as a password for the cluster. SmartSense is a way for Hortonworks to collect telemetry about your usage and your services. I recommend you to turn this on. You don't have to. In here, I will be picking my own SSH key name. If you don't have a SSH key yet, click on the link below. I have a tutorial built in place to show you how to create your own SSH key in AWS. The remote access in here, I'll be allowing the entire world to have access to it. So I'll be using 0000 WAC 0. Click forward. You can tag your instances. In this case, I choose not to. And then I click on Next to verify my deployment. Once I verify my deployment, you have to acknowledge that AWS CloudFormation will create IAM resources for you. What this means is we'll launch instance on behalf of you, and then you can click on Create to get the process started. Completed. In here, if you click on the newly created cluster and then click on Outputs, it will load up the proper URL for you to access the cluster management console. Click on this will land you into a new management page. Sometimes you will see a warning for SSL. In this case, I just haven't set up the SSL certificate. You can click on Proceed to ignore the warning. In production environment, you will usually set up your SSL certificate through a proxy or through some kind of a web load balancer. In that case, you will not see this kind of warning. So I log in with my username and password. The page will load up the clusters that you have already spun up. In this case, I already have one cluster running for a few days. For the purpose for this tutorial, we'll be creating a new cluster. Click on Create. In here, I'll be using a name for the tutorial. So I'll do Hive tutorial C2, means cluster 2. I'll be using the HTTP 2.5 cloud version, and then I want to make sure you check EDW analytics. Remember, this is for running analytical jobs, not ETL jobs, with Apache Hive LLAP 2, as well as Zeppelin. The instance types I recommend for this tutorial will be one master node with 16 gig of memory, where the worker instances will be 3 instance type of M2, M3, 2x large that has 8 CPU as well as 30 gig RAM. This helps a lot because LLAP depends on memory for query caching. LLAP depends on the memory on nodes for data caching when running queries, especially when your data is stored in a separate physical location, in this case, for example, in S3. The initial query will run relatively slow because the cluster needs to transition the data from an external location to within your cluster. But the large amount of memory allows the cluster to cache this data within memory, allowing you to achieve really, really fast query speeds for the data sets you need. The SSH key name will be using the one that I've used before. Remote access, again, enabled to everybody. The cluster user, I will be using a default username admin, and then I'll use my own password for the purpose for this demo. And the open access to web UI also opens the necessary ports for the cluster to give you access. Now there's a little bit more further tweaking. Let's get started with the cluster creation. It does a few verifications, and then we say yes, confirm creation. And then the Hortonworks cluster controller kicks into high gear, start creating the cluster for you. So it does infrastructure refreshes, first understand what is available in your infrastructure, and it goes through all the necessary steps to allocate the resources, build out the VMs, as well as load up all the configuration file. This process usually takes about 10 to 15 minutes. We will speed it up here, and then we'll come back to here once the cluster creation has been completed. All right. After 15 minutes or so, the cluster creation has been completed. As you can see in here, it says running. In here, what we want to do is we want to start with Improv. But before we do that, after 15 minutes or so, the cluster creation has been completed. In our case, we want to do some initial tuning. Let's go into Improv first, Improv Web UI. In here, you will be asked to type in your username and password that you have used during cluster creation, which I have already typed in. After 15 minutes or so, the cluster creation has been completed. Let's get started. So first, open Improv Web. In this page, you will be asked to provide your username and password. This is different than the cluster administration's password because you might have different administrators for individual clusters. So in this case, this is the one that I've supplied during the cluster creation. We want to do some initial tuning for the cluster because depending on the size of the memory and CPU of your instances, you might be able to get more performance out of this. And it's very vital for us to capture those. First, you want to go into Yarn, go into configurations. Yarn is a container management technology used by Hadoop cluster, slightly more memory to work with. So in this case, we'll be giving it about 28 gig of RAM. And then we want to reduce the size of the containers for individual Yarn jobs. This makes the containers more granular and makes it easier for a cluster to run smaller jobs. Click on Save. We want to do some tuning changes, and click on Save. The cluster will go through and then do some optimizations based on the two input we have provided. And it will tell us there are some components requiring restart. So we want to do a restart all affected, and then do confirm all restart. This will cycle through all the individual components and daemons and services to load the latest configuration file. So at this point, you have your cluster up and running, and you have already tuned your cluster to run your query very efficiently. What we're going to do next is we will be creating the tables, loading the data in, and then start running some analysis. So the first thing you want to do is you want to go to the Hive view in here. The Hive view allows you to run essentially arbitrary queries against the database. So this is a script I've already created, and then I'll explain once we start running it. Just copy and paste into the Hive view to start execution. What this script does is it drops the existing tables, and then it starts creating tables one by one: airports, airlines, the planes, and then the flights. And as you can see, the tables actually exist in S3 instead of locally on the HDFS. As we will be demonstrating later, there's a way to copy the data in. So it's already finished. The next thing we're going to do is we will grab the load and optimize query and then run the first line to repair. This is actually not repairing the table, but rather given our files exist in individual partition files. What this does is it reloads all the partitions from S3 bucket into your table so that we actually have some data to play with. So next step is let's do some analysis. Let's start with Tableau. So it's a very popular data visualization tool. You don't have to use Tableau. It works with Excel because we have a ODBC driver available as well. You want to connect to server. In this case, we'll be using the Hortonworks Hadoop Hive server. Now, if it doesn't show up here, don't worry. Click on More, and then you will be able to find it. This list is sorted based on how frequent you use those services. So in here, you want to copy the IP address string used by your Embari dashboard because it's the same server. And then in here, you click on Hortonworks Hadoop Hive, paste in the IP address. Now, in type, you want to make sure you select Hive Server 2, and then make sure your port is 10500. Now, if you cannot connect to this port for some reason, you have to double check in the previous part of this video where I showed you how to enable this port through AWS security policies. Such that you can actually connect to this port. Now, Hive Server requires you to authenticate with username and password, and you can use any arbitrary username and password because we haven't secured the cluster yet. Sign in. After you have connected to Tableau, we are going to start with selecting a schema. In this case, we will be using the default schema. And to load all the tables, click on this little search icon. Now, I have a lot more tables than you will see. For you, you'll just see 4 tables in here. I have some other tables that has copies of the data. So what you will do is you want to start with the flights table. This is the fact table. It contains all the individual flights. And then we will be dragging in the airlines table. And then we want to join those tables together. So we will be using unique carrier equals to code because that's how they identify each other. And then we want to drag in planes. You want to click on the join. Instead of using year, we will be using tail number. The reason being, by default, there's year column in both tables, so Tableau automatically matches them. But in this case, the tail number is the unique identifier for planes. Now, airports is a little bit more interesting because there is a source airport and then a destination airport. So what we will do is we will use origin equals to IATA. Now, IATA is the International Airport Identifier, right? So it's how we are going to use this data. That was the origin. So let's double click on this and then name it so, because we are going to use the same table twice. Now drag in the airports table again, and then this time we are going to match the destination to IATA. And we will name the airport as destination. And that is our data model, right? Fairly straightforward. All right, once you have the data model ready, let's get started to do some interesting visualizations. The first thing I am really curious about is how well are each of the airlines performing. So let's take a look at what are the airlines doing in the past few years. One thing that I am interested in is, let's say, what happens since 2003. Right, so I will do a quick filter for the year, and then I will plot the date of flight, and then I am interested in what are the airlines, so I'll be using descriptions. And then I am interested in how many flights they have generated for that year. So I drag in Improv Records in here. As you can see, right, the query is fairly interactive. It doesn't take much time to run. So let me do maybe an error chart. So what this does is it will plot the data and then stack them together. This one takes a little bit of time because it needs to change the way that group by works. So as you can see, right, we have the data divided based on the airlines into individual rows. But instead of showing this as a description, I want to use just a colored area. Oh, that looks much nicer, right? As you can see, the overall trend has been growing from 2003 all the way to 2007. And then as you can see, there's a global slowdown of economic. But I'm really curious to find out, what are some of those individual ones, right? So what we can do is we can use the label feature. So I'll just drag the description onto label. And this will basically highlight individual airlines. And then as you can see, right, Southwest Airline has been extremely successful during that time. And then also US Airways with their opening of European flights. You can see a significant growth in their adoption as well. So that's something interesting. So we'll call this airline growth trend. As a free controller, I want to find out what are the airports to avoid when I book my transition tickets, for example. So one thing what I can do is I can plot, how likely I'm going to have terrible delays in individual airports. Now, one of the measures you have here is called departure delay. Let's find that one. So DEP delay. If I'm going to airport and then if the airplane is delaying for, say 10, 15 minutes, that's not terrible, right? But once it reaches like half an hour, that's pretty terrible. So what we want to do is we want to produce a binary category between ready delay, which is half an hour, and then not too bad, right, which is within half an hour. So right click on departure delay, and then we will create a calculated field. What we will do is this delayed? Right, so this is just the name of it. So what we're going to do is we will write a very simple formula to do this. So if departure delay is greater than 30, then we'll say then it's true, right? So it's ready delayed. Otherwise, it's false, and then end. So this will be our computing block, and it will do a new measure in here, right, to say whether this one's delayed. So what I'll do is I will put that into the columns, right? Now, this one takes some time to execute because it needs to go into individual rows and then figure out, how likely it's delayed, even though there's no number, but you guys will see it's actually fairly fast if we want to see the records. So let's find the number of records. So once we have the number of records generated, we notice there are some nulls because the reason is some of them doesn't have the delayed number captured because the flight never happened. So what we want to do is we want to filter this out, right? So we'll say the flight which didn't actually happen at all. Let's remove those from our analysis. And I want to cross-reference this against which airport, right? So I'll find the original airport and then which city they're leaving from. So we have some numbers. Now, we can sort those numbers. That's one way to see it, right? But the other really interesting way we can do this is we can do a geography map. So click on the map, right? You can see there's little pie charts in here, right? There's little pie charts. So we don't really care about airports in Alaska, say for example, right? So we want to do a filter on the state. So we'll drag this into the state. It will list. So we care about everything, but not Alaska. So it will rerun the query with this new filter in place, and you can see the results once it returns. We have, centered our maps, right, basically in the lower 50 states of the United States. You can see those little pie charts, right? They're not like super obvious. So what you can do is you can increase the size of them, and then they become much more obvious. From a flights perspective, as you can see there, it's like super easy to figure out. The size of the pie identifies how many flights are going in and outside of the airports, and then the little angle of the pie shows you how many flights are being delayed, right? As you can see, right, it's actually pretty terrible in Chicago and Atlanta. But we want to see if there's any changes, right, in trend. So what we can do is we can use the year as a way to show multiple years of flights. So what we'll do is we'll do a filter. Let's say we care about the last 3 years, right, in this record. So this will pull in the year data. Let's say we care about the record at least from 2006. We run this again, and then we will also be using the year as a way to segregate our data. 1, 2, 3. Now this one looks kind of weird, right? It's just because the year itself is considered to be a measure, to be a continuous. So let's change this one to discrete, and then now you have a much better chart across time, right? And then we probably want to see this horizontally instead of vertically, so dragging that to columns. So you have 2006, 7, and 8. Now the other thing is the charts looks pretty busy, right? Because from the smaller airports, they have too few flights, so I don't really care about them. What we can do is I can right-click on the sum and then do show filter. So what this does is it creates a interactive filter that allows me to filter for different flights, for different number of flights. So what I can do is I can just drag this. Right? As you can see, all those are extremely interactive. Right? It removes all the flights, all the airports with fewer than a certain number of flights that's delayed. And I can keep increasing the minimum threshold, right? And then the size is kind of too big. So let's tune that back down, right? And then you can see, right? So 2 airports definitely to avoid. One is Atlanta, one is Chicago. But if you're flying certain companies, you can avoid them. And then on the East Coast, there's obviously the JFK and the New York airports, which are pretty terrible back in 2007. So that's another one. So let's name this, airport percentage delayed. And from here, you can create dashboard, you can create stories, and then many other interesting visualizations. But the whole point of this tutorial is to show you, it's actually fairly straightforward to set up Hive in the AWS cloud, and you can run fairly interactive data explorations using various tools such as Tableau to explore and then analyze your data. I hope this tutorial is interesting for you, and if you have any questions or concerns, feel free to leave a comment below, or you can also reach the entire company of Hortonworks at Horton Community Connections, HCC, and happy data exploration.